So in this video, we're going to look at some of the legacies of the Renaissance. You know, um, because of the Renaissance, because of this great change that started sometime in the 14th and then early 15th centuries, what are the changes that man has experienced? So there's a number of different ways that we could look at this or talk about this subject. I thought it would be fun because of a question that we got in the discussion section to look first at the legacy of the Renaissance on the institution of science. So the question, which was a good one, was, hey, is the Renaissance just about art, or is the Renaissance applicable in other places? And I sincerely hope that I didn't give you guys that impression. So I love art and architecture, so that those are two things that I really enjoy talking about. But I've said from the very beginning that the Renaissance is really about a change in value. What are the things that modern man is going to value as opposed to man from the medieval period? So we can certainly use science to look at that. Well, you know, we'd like to see the Renaissance as this sea change. Like we snap our fingers, and here we are, and now it's 1520, and man has become a more modern version of himself. But of course, that's not true. So many of these institutions that we associate with the science of the medieval era will continue into the 15th, 16th, and 17th centuries. First of all, the term science is a relatively modern word. So when we talk about scientific inquiry, or we talk about what today is accepted as science, the term that our Renaissance ancestors would have used, or people would have used in the 16th, 17th, and even 18th century, is natural philosophy. So what are our natural philosophers interested in doing? Well, when we talk about early Renaissance science, and when we talk about science of the late medieval age, one of the things we'd need to talk about is alchemy. So I have an alchemist there doing some alchemy. He's mixing some elements together. He's looking for an item called the Philosopher's Stone, and of course, he is trying to turn one element into another element. He's trying to turn lead into gold. Good luck with that, especially with gold prices being what they are. So that was one of the objectives of medieval alchemists. And the other thing that I wanted to bring up when we talk about medieval man and their scientific or non-scientific approaches. This is the age of alchemy. It's also the age of witchcraft and witch hunts and witch trials. So those of you who are familiar with American history will note the Salem witchcraft trials, which occurred in the late 1600s, the latter part of the 17th century in Massachusetts. That was an age when witchcraft trials were very much on the decline in Europe, but through the 1400s, 1500s, and early 1600s, they were all the rage. We think that millions of people may have been caught up in witchcraft trials and killed in all sorts of terrible ways. In fact, there was a very popular book published called the Malleus Maleficarum, which translates from the Latin as the Hammer of Witches, which was kind of a how-to guide. Took the Pope's advice, took some biblical advice, and then a practical guide on how to hunt witches and find them out, and the scientific approach that one could take using inquiry and using like an inquisitory techniques to figure out who's a witch and who's not a witch. And then, of course, witches being guilty of heresy and being in league with the devil had to be burned or other nasty things. So even though we like to think that the Renaissance is the age of modern man, the emergence of modern man, for most people, it was the age of alchemy, it was the age of witches, it was the age of witchcraft. But things are beginning to change. And I think when we look at science in the Renaissance, it's probably in our best interest to kind of like look at a couple different, like a couple like very specific areas. So one of the places that I'd like to go is the science of navigation, the science of getting our ships from point A to point B. So this has a very practical application. We want to be able to take ships out on the open ocean. So man has been using boats and ships since before recorded history. But the secret was always staying within view of the shore. That way you wouldn't get lost. So starting in the Middle Ages, there are advances in technology. Many of them, by the way, come from the Arab world, come from the Middle East, that will allow Europeans to leave the sight of the shore. So I wanted to bring up a couple of those instruments of navigation, scientific instruments, demonstrate how one kind of builds on top of the other, because these are the inventions that allow Columbus and Magellan and the sailors who sailed for Prince Henry the Navigator in Portugal to go and find a way to circumnavigate Africa, or circumnavigate the globe in Magellan's case. So here is an astrolabe. Astrolabe is a scientific instrument that allows a navigator, a sailor, to take the position of heavenly bodies. So at nighttime or in the daytime, you figure out where you figure out the time of day, and then you figure out the day of the month, the day of the year. And if you know the time and you know the location of the heavenly body, then you can figure out where you are north or south of the equator. So you can take your latitude. I know how far north or how far south. An easier way to do it is with this invention that you may be more familiar with. It's called a sextant. So this allows sailors to take, it's still used today, by the way. It allows sailors to take the position of the sun, or take the position of another heavenly body at night, and you can figure out how far north or south of the equator you are. Take the ship's position. So latitude. And this is the sailor's best friend. This is a magnetic compass. So really useful for orienteering when you're on land too. Magnetic compass allows you to know the direction of polar north. So you can figure out in what direction you are traveling. So if you combine compass and sextant, or compass and astrolabe, navigators were confident going out of sight of land, which opened up a lot of maritime opportunities for commerce and eventually for exploration. Now you might be thinking, well, that's all well and good if we know our latitude, but what about longitude? Longitude will come a lot later. There is a way that you can approximate longitude using a sextant, but the real problem, the real solution to the longitude problem, how far east or west of the prime meridian am I? That solution won't come until hundreds of years later, when very accurate timepieces are made possible through the science of miniaturization. But that's for another course. So the science of navigation. And I did show you Hans Holbein's famous painting, The Ambassadors, and there's a couple of astronomical aids and and navigational aids that are part of the painting. So if you wanted to jump back and take a look at that painting again, you'll notice a number of navigational aids and timekeeping aids. So what is it that we're talking about here? So this entire course has been built around the culture and the art of the Renaissance, but the Renaissance, which I like to date back to the writings of Petrarch and this emerging spirit of classicism and individualism and humanism, takes us directly to the scientific revolution. So this is an early 15th, 16th century movement that was a direct result of the skepticism and individualism that we associate with the Renaissance period. But it's not the same. You know, one of the things, or if we talk about the values of the Renaissance, one of those core values is classicism. You know, there was something great about civilization of the ancients. The ancient Greek, ancient Roman civilization was really onto something, and all human knowledge was discovered and then lost, or discovered and then devalued. So if we bring back those periods, then we can reclaim the height of human civilization. That's a spirit of the Renaissance. But you're not going to see that classicism in the scientific revolution. A lot of these guys, Isaac Newton, Sir Francis Bacon, are going to try to use empiricism. They're going to look at the world around them and use data collection and observations to add knowledge to humanity that the Romans or Greeks didn't have access to. So in many ways, the scientific revolution will be like a step forward or a step beyond the Renaissance. But when we talk about the early 16th century, I mean, this is the height of the Renaissance. This is the high Renaissance. So people like Copernicus and Galileo and Kepler and Brahe are all contemporaries of Michelangelo and Leonardo and Raphael and Tintoretto. So if there's one scientific discipline that we could use to really explain the scientific advances of the 16th century during this Renaissance period and the early part of the scientific revolution, it is astronomy. So we can start with some classical knowledge. So here we are in the 2nd century. That is a Greek philosopher / scientist named Ptolemy. And this is Ptolemy's geocentric model of the solar system. So this is what the ancients, using their powers of observation, were able to conceive of the solar system or the universe. So if you notice, there's the Earth, smack dab in the middle. That's the philosophy of Aristotle. That's Aristotelian physics. The Earth is at the center. It is fixed. It does not move. The moon and the planets and the sun orbit the Earth. They revolve around the Earth. And then the stars are fixed points that surround the Earth in some kind of crystal-like sphere that encloses the entire system. This is the geocentric model. Here we have a Polish man who lived and taught for a long time in Prague, but also in Warsaw, named Nicholas Copernicus. And just using math and observation, most of the observations came with the naked eye, he's proposing a new kind of system. So he's saying that this Ptolemaic geocentric theory of the universe, of the solar system, is wrong. The math just doesn't work. So he publishes a controversial book called On the Revolutions of Heavenly Bodies, On the Revolutions of the Celestial Spheres, which is one of the most important books published not just during the Renaissance, but maybe in the history of mankind. It is a direct challenge. This is the legacy of Lorenzo Valla and his exculpatory work on the donation of Constantine. This is, I am skeptical of what is in front of me, and I'm going to challenge what the church is telling me, and I'm going to challenge what Aristotle has told me, and I'm going to challenge what Ptolemy has told me. And in this model, Copernicus is going to put not the Earth, but the sun at the center of the solar system. This is the so-called heliocentric theory. So there it is. So Ptolemy's model wasn't as simplistic as you might think. If we go back to Ptolemy for a second, Ptolemy really realized something, and everybody that had looked at the night sky in between Ptolemy and Copernicus had to deal with a central issue. So, okay, the stars don't move. I got it. The moon revolves around the Earth. That's pretty easy. It does. The moon orbits the Earth. We know that's true. The sun appears to orbit the Earth, so it rises and it sets. So that's easy. But what about the planets? The planets don't behave as if they orbited the Earth. There's no fixed or regular pattern to the way that they are moving back and forth in the sky. So if the Earth were fixed and the planets are moving, then why is it that Mars all of a sudden stops and then looks like it's going in another direction? Why does it look like Venus is, making an abrupt right-hand turn? There's really no way to justify that mathematically. It's certainly not orderly. And so these guys invent a whole kind of brand new fuzzy math to explain why, or to justify why Venus operates the way it does, why Mars operates the way it does for the planets. So Copernicus, this is a great, so when I tell this story to my high school students, this is a great opportunity to explain the theory of Occam's razor, right? The idea that if you have two possible solutions to a problem, the one that is the simpler is probably the one that's correct. This is Copernicus's revolutionary, groundbreaking, a little bit seditious model for the solar system. But he didn't get everything right either, if you notice. I mean, he's got Earth, he's got the moon revolving around Earth, and he's got the planets revolving around the sun and the Earth revolving around the sun. But notice what he doesn't have. The criticism of Copernicus, which fellow astronomers picked up almost immediately, is that the math doesn't really work out here either. What's to explain, why planets appear to be moving faster at certain times of the year. The Danish astronomer nobleman Tycho Brahe came up with this model. It was a challenge to Copernicus. So here we have the beginnings of what we might call the scientific method. I'm going to use math and observation to challenge your model, and let's duke it out and see who's right. So he goes back and places the Earth back at the center of the solar system. I'm sorry, places the sun back at I was right the first time. Places the Earth back at the center of the solar system and has the moon and the sun revolving around the Earth, but then has the planets correctly revolving around the sun. Kepler is the guy who figures it out. So Kepler takes Copernicus's theory, looks at Brahe's theory, and says, well, the math will work if the planets and the Earth orbit the sun not as perfect circles, but as ellipses. So we know this is what it really looks like. This is closer to the truth here. Um, it's to figure out why this works or why this is the way it is. We're going to need Isaac Newton. Geez, we're gonna probably can use a little bit of Einstein here too. By the way, there are still people who want to argue with me that the Earth is at the center of the solar system, and the Earth. A lot of celebrities have come out in the last couple of years uh, who are popular with teenagers and will argue for flat Earth theory, which I just don't understand. Here we are, people in the universe, without the help of a telescope, are figuring this stuff out using math and logic and just simple observation. Tell you who did have a telescope, and that's Galileo. So Galileo is the most important astronomer of the age, and he takes Copernicus's work and Brahe's work and Kepler's work, and he is able to, through experimentation and observation, prove the hypothesis of Copernicus and the hypothesis of Kepler. Why did he have a telescope? Because remember that little trip that we took through Venice? Glassmaking has become better and better and better. And he simply combines highly crafted, highly polished lenses and is able to craft the first modern telescope. Call him a Renaissance man. I think that's fair. As a physicist and an astronomer, he was actually pretty good friends, was Galileo, with the Pope at the time. But when he starts writing proofs, mathematical proofs of Kepler's theory and Copernicus's theory, the Pope is livid and invites the Roman Inquisition to investigate Galileo for heresy. And very famously, he's forced to recant his works and live in under a kind of house arrest in Florence for the rest of his life. But Copernicus was writing and working in Poland at a time when Poland was under the sway of the Protestant Reformation. He was working in France when France was a little bit more open-minded. Kepler was a Northern European. Brahe was Northern European. So the places in Europe where the Catholic Church had the most influence tended to go after these guys pretty hard. Now, the interesting thing there is when the Catholic Counter-Reformation starts and St. Ignatius of Loyola begins the Jesuit order, we start to associate the Catholic Church with scholarship and inquiry, which is kind of an interesting 180. And I'll talk about that a little bit when I get to the video on the Counter-Reformation. But that's the story of Galileo Galilei. One of the things that he was able to identify, if you look at the bottom right, that's Jupiter, the largest planet in the solar system. But he identified the 4 largest moons. He saw them with his telescope. He wanted to name them the Medici moons because his client was the Medici family, the Medicean moons, and that was just smart by Galileo. Today we call them the Galilean moons in honor of Galileo. There's a great apocryphal story, I wish it were true, that when he is forced to recant his scholarly work and forced to give up the Copernican theory, the heliocentric model, and say in front of everybody that Ptolemy was right and the Earth is a fixed, unmoving point at the center of the solar system, the center of the universe. He whispered under his breath, "Yet it still moves." Wish it were true. It's not true. It's apocryphal. But Galileo dies under house arrest. The church, by the way, the Catholic Church didn't apologize for their treatment of Galileo until the 1990s. So that's a little foray into astronomy. We could do the same thing with anatomy. You know, what Galileo and Copernicus were to astronomy, Andreas Vesalius is to anatomy. So we look at seminal books like On the Rotations of Heavenly Spheres, or Galileo's famous book Starry Messenger. Andreas Vesalius had one called On the Fabric of the Human Body, which is the seminal work on anatomy. Galen, who was a Greek physician who lived in the Roman Empire, had done exhaustive studies on the human body and had written these texts, these treatises on anatomy, which were accepted during the medieval age as, the be-all, end-all of anatomy. And he said some interesting things that today we'd look at, and Galen said things like, men had more teeth than women. Nobody thought to challenge that because Galen said it. Or the humerus is equal in size to the tibia. No one thought to challenge that because Galen said it. This is how the circulatory system works. Well, a lot of what he said was interesting, and a lot of it was really ahead of its time for the 2nd century AD, but a lot of it was ascientific. But medieval man wasn't studying the human body. And even earlier in the Renaissance, there was a general prohibition throughout Christian Europe on dissection, which is the tool that we use today to teach doctors how to be doctors and to learn about the human body. People were dissecting animals, and in a few cases, early Renaissance doctors were dissecting apes from North Africa, but nobody was dissecting the human body because of the sanctity of the human body. And here we see attitudes start to change, and people like Vesalius and even Leonardo are taking a closer look at the body. One of the things that I said in an earlier video, which I think is true of the Renaissance, is that the classical influence helps us understand that the human body is not a vessel for sin. The human body is not something to be ashamed of. The human body is something to be celebrated, and man has dignity. This is one of Leonardo da Vinci's famous sketches. You would have to go. I saw it at the Louvre in 2019. I was just lucky because it hardly ever goes on display because it's on parchment. Typically, it's kept in Venice. This is called Vitruvian Man. Vitruvius was a Roman architect, and he made some observations about the human body and human form and human like the length and the width of the human body in relation to itself, and he was doing a study on symmetry. Leonardo da Vinci takes that and attempts to do a study here that proves or disproves that theory. So some really interesting things, and Leonardo is an interesting guy but an odd guy. So if you want to read the script there, well, number one, it's in Italian. Number two, he wrote it backwards. Leonardo was left-handed, but why did he write it in mirror script? That's a great question. But he says some interesting things here, like the maximum width of the shoulders is a quarter of the height of a man. So just interesting. Here's some of Vesalius' sketches. He does the musculature. He does anatomy. And Vesalius tells us so many things that are so important to like modern doctors. How to treat ailments. He's the first guy to talk about diet as being important to someone's medical health. How to treat illnesses with diet. So, a little bit about anatomy, a little bit about astronomy, a little bit about navigation. So, a little bit about science in the Renaissance and how the values of the Renaissance help inform scientific inquiry moving forward. If you're interested in this period, the place to look is what we call the scientific revolution, and that's a 16th century phenomenon.